Hey guys, here's another video showing you how to do one of these optimization problems. This one's a little different. It says find the area of the largest rectangle that can be inscribed in a right triangle with legs of length 3 and 4, um, assuming the two sides of the rectangle lie along the legs. So let's put that all together. First things first, we have a right triangle with legs 3 and 4. So maybe we should start there. That's the thing we can lock in for sure. So here's a right triangle, legs 3 and 4. Of course, it's a 3, 4, 5. Pythagorean triple. I'm not sure we're going to need the hypotenuse here, but might as well just put it there anyway. We have a rectangle inscribed where the sides lie along the legs. So, if one side is here, maybe the rectangle comes out to here and then comes down like that. So one of the sides of the rectangle is on this leg, one of the sides of this rectangle is on this leg, and the 4, of course, is the entire leg, and the 3, of course, is this entire leg. So we don't really have representation for the rectangle parts yet, but we will. So we're trying to find the actual maximum area of that rectangle. So let's call the rectangle like this side X and this side Y. So that means that's Y, that's X. And the area, of course, of the rectangle would simply be X times Y. But again, we have two variables here. We need to somehow find a way to relate the other two variables to, or the two variables themselves, so we can substitute in and actually maximize this equation. So I notice, when you draw in this rectangle, hopefully you can see, you make this little triangle here, this little triangle right here. I wish I didn't grab my other color pen, but just look at this thicker triangle down here. This little triangle and the big right triangle are similar because they're both right triangles and they share this angle. So these two triangles are similar. Second, just refocus there. There we go. So that means I can set up a proportion. So this side right here, if the whole side is 4 and this part is x, this side right here is 4 minus x. So the bottom of the little triangle, 4 minus x, over the bottom of the big triangle should be, that should be a 4, I'm sorry. That's a 4, that's a 4. Should be equal to the sort of the height here of the small triangle, the left side, which is y, over the entire left side of the big triangle, which is 3. So bottom to bottom, left to left, there's your proportion. So 12 minus 3x equals 4y. 12 minus 3x over 4 equals y. My 4's and my y's kind of look alike. Sorry about that. And now we can substitute. So my area is going to be x times 12 minus 3x over 4. I can simplify that a little bit. My area is going to be, that's just 3, so 3x minus 3/4 x squared. And I think we're ready to differentiate and figure out what the maximum value of this would be. So my derivative is going to be 3 minus 3/2 x. So when is that equal to 0? That's going to be 3/2 x equals 3, so x equals 2. So if x is 2, I can plug that in to get y. That's going to be 3/2. And I believe the question says, what is the actual area of the largest rectangle? So it would simply be 2 times 3/2 or 3. And that's going to be square centimeters. And I think we're good to go. All right, I hope that helps. If you have any other questions, be sure and let me know. And I will see you guys later.